So, today we begin another unit, and today kinematics is the study of motion. It comes from the Greek word kinema, which means movement, and you might recognize the word cinema from motion pictures. So, all about different types of motion. What sort of topics will we study? In kinematics, we're going to study two quantities in particular. We're going to talk about velocity and acceleration a lot. And another topic towards the end will be about projectile motion. Projectile motion is the motion of an object through the air. Like if you were to throw a ball, the ball would be a projectile in motion, so projectile motion. The first major quantity in kinematics that we will study is velocity. Velocity is the measurement of the speed, but also the direction an object is moving. It combines two quantities that we've studied so far, length and time. Velocity is a vector, meaning it has both a speed, but it also has a direction. Now the speed is the magnitude of a vector, and that's what's normally measured by your speedometer, whereas the direction might be forward, backwards, up, down, left, right. So it could be even a combination of some of those things. Now, let's get technical. The definition for average velocity is that it is a change in position over a change in time, which brings us to our first kinematics formula. The definition of velocity is pretty straightforward. There are three quantities in it. The V, of course, stands for velocity, and the arrow that's on top simply reminds us that velocity is a vector, and so it has a direction component to it that we have to keep in mind at times. The other side of the equation has S over here, stands for position. In this entire chapter, that's probably the trickiest thing. Why they didn't use the letter P or maybe the letter D for distance, I'm not entirely sure. Now let's think about the units of velocity. Since velocity is a distance or a change in position over a change in time, it makes sense that we would use the standard unit of distance, that is meters, over the standard unit of time, which is seconds. So the standard unit of velocity is meters per second. Now there are many other velocity units that are often used. In the English system, the standard unit would be feet per second. Although here in America, most of the velocities we're familiar with are in miles per hour. In Canada or many metric using countries, they measure their speeds in kilometers per hour. And if you've ever been sailing, you know that the speeds there are measured in knots. Off to the side, you'll see a list of different velocity conversions. I would highly suggest that you write several of these down on a note card. The top is only an approximation, but is one that we can use quite frequently to convert things into what we're more familiar with, miles per hour. Underneath, these are exact definitions. 1 meter per second is exactly 2.237 miles per hour, and exactly 3.6 kilometers per hour. Underneath here is another very useful exact conversion. 88 feet per second is exactly 60 miles per hour. Here, this is the speed of light, not specifically a conversion factor per se, but a pretty important number to know nonetheless. And underneath here is a exact conversion for knots. A knot is about half of a meter per second. So let's do a quick example of how to make a conversion so that you know how to do it if you're ever asked. How fast in feet per second is 60 miles per hour? Any time we do a conversion, I would start with the speed that we've been given, 60. And here it's important to know that miles per hour can be broken into miles on top and hours on the bottom. This allows us to convert miles into feet and hours into seconds using the distance and time conversions that we remember. To go from miles into feet, remember that 1 mile is 5,280 feet. And to convert hours into seconds, you can remember that there is 1 hour in 60 minutes, or 60 minutes in 1 hour, and there are 60 seconds in 1 minute. And we've got miles canceling out with miles, hours with hours, minutes with minutes, and the only units left are feet and seconds, which is what we were asked to find, feet per second. And now we can calculate that easy enough. 60 times 5,280 divided by 60 divided by 60. Notice that is exactly 88 feet per second. So 60 miles per hour is exactly 88 feet per second, which is pretty close to 90 feet per second. And you might know that a meter is pretty close to 3 feet, which is a yard. They're not exactly the same, but that would mean that 90 feet per second would be pretty close to 30 meters per second. And if we take each of these factors and divide by 30, this gives us a very useful approximation that 1 meter per second is approximately 2 miles per hour, or approximately 3 feet per second. Since most of the time we'll be given Since most of the time we'll be given things in meters per second, it's useful to know that doubling that gives us the more familiar miles per hour. Now let's look at some example problems involving average velocity. First, a student travels at an average speed of 63 miles per hour. Suppose it took her 5 hours to get home. How far did she travel? We can answer this question using the definition of average velocity. That is the total distance divided by the total time. We were told the velocity is 63. Total distance is what we are looking for. And the total amount of time is 5 hours. If we multiply both sides by 5, we get pretty quickly that the total distance is 315 miles. If this student had traveled at 80 miles per hour instead of 63, how long would it have taken? Again, we can use the formula V equals delta S over delta T. And this time we're looking for delta T. Our speed is 80 miles per hour, and the distance is 315 miles. And we're looking for time. A useful trick in a situation like this is that the left-hand side and the denominator here can just be interchanged. And we find the time to be 315 divided by 80, or 3.9 hours. In our third example, we want to know if it took her 4 hours and 30 minutes to get home, was she speeding? We can use the same formula again. The average velocity is the distance divided by the time. And in this case, the distance is 315 miles still. And the time is 4.5 hours. 30 minutes is half an hour. And 315 divided by 4.5 is exactly 70 miles per hour. So, was she speeding? Probably, actually. Remember that this is an average velocity, and so if her average velocity was 70 miles per hour, that means at times she probably was going less than 70 miles per hour, and at other times she was going more than 70 miles per hour. And unless she instantly got on the freeway and instantly got off when she got home, she must have at some point been traveling higher than 70 miles per hour. Finally, when traveling to Florida, she averaged 600 miles at 70 miles per hour, and then averaged the other 600 miles at 50 miles per hour. We'd like to know what her average speed for the whole trip is. The quick answer might be to say 70 miles per hour for half the trip and 50 miles per hour for half the trip, so the average must have been exactly halfway in between, 60 miles per hour. But that implies that she traveled at 70 miles per hour for half the time and 50 miles per hour for half the time, which is not true. But she's actually traveling at 50 miles per hour for a lot longer than for 70 miles per hour. That's the key for answering a question like this. Her average speed is equal to the total distance divided by the total time. So, the total distance is easy enough. That's 600 plus 600, or 1,200 total miles. The total time is not quite as easy. She was traveling for 70 miles per hour for the first half of her trip. So the time it took for her to go that far is 600 miles divided by 70. But she was also traveling 600 miles at 50 miles per hour. The first part of her trip, when she was traveling at 70 miles per hour, took 8.5 hours, while the second part of her trip, traveling at 50 miles per hour, took 12 hours. Notice she was spending quite a bit more time traveling at the slower speed. So rather than 60 miles per hour as an average speed, I would suspect her average speed to be a little less than that. If we take these two times and add them together, I'll round it to 8.57 hours. That gives a total time for the trip of 20.57. Now we can take the total distance and divide it by the total time, and we get an average speed of 58 miles per hour.